Today's lesson, section 5.6b, and we're talking about modeling harmonic motion. So here I have a problem called the variable star problem, and we're going to use this as our example to help us see how we model harmonic motion. And so let's read it together. A variable star is one whose brightness to an observer on Earth fluctuates in a periodic way. Sinusoids can model the brightness of these stars. Suppose the variable star, delta prime, has an average brightness or magnitude of 3.4 and the time between periods of maximum brightness is 8.8 days. The brightness varies from an average by as much as magnitude of 1.2. If we let time begin when star is at average magnitude and decreasing in brightness, what we want to do is, on a graph paper, graph at least one cycle of the sinusoid, which describes the brightness of delta prime, and write a function that represents this analytically. Number 2, when is the first time the brightness is 3.4 after time 0, and then round to 2 places. Then 3, the star's brightness is considered superlative when the magnitude is above 4.5. Find the first time interval after time 0 for which this happens. How long does the superlative interval last? Round to 2 places. So let's use that first data and let's graph it. So let's go make a graph. Now here, remember, your graph can be at any different interval you want it to be at. So for your time, since a period is the length of 8.8 days, how about we make it into 8.8 days, the length of our graph. Now, like we usually do with period, the period's 8.8. We want to break that into fours, so every interval should be at a distance of 2.2 away. So starting at 0, we'll make this 2.2, this one will be 4.4, and then this one will be 6.6. Now if we look back, it says the average brightness of or magnitude of the star is 3.4 for delta prime. So we want to kind of make that our middle on our picture. So here, let's go with, so because your middle is 3.4, let's go with going every 1.7. And I think that's all we'll need for this. So if it's average, think about what they said at the beginning. They want us to draw a graph at least one cycle and write an equation. So if it varies in between that by 1.2, so you're going to start your graph start at average and is going decreasing. So when we draw our picture, starting at average would be 3.4, and then if you're changing every 1.2, that's like your amplitude. Then we would go down 1.2, so that'd be like 2.2. So now let's label this point just so we have it here, so you're not confused on what it should be. So it should be 2.2, comma 2.2. This one will be 0, comma 3.4. Now because this is like your sinusoidal graph, so it's either sine or cosine, so it should oscillate back up to the average which would be 3.4. So 4.4 is the x value, or the t value in this case, comma 3.4. And then you continue to oscillate, so difference on the top side would be 1.2. So we could say that this is 6.6, comma, and then 1.2 away from 3.4 on the positive side would be 4.6. And then we would come back down to our average, which would be 3.4. So at 8.8, comma 3.4. So then we get a graph that looks like that. Oh, just a second. Looks like I graphed my... There. That's better. Okay, so then that's one period of our value, or of our sinusoidal graph. So now for A, so we graphed it, so that's that part, and now I want to be able to write our equation. So y equals, so thinking about which graph we're looking at. Now this one, since we're starting in the middle and either going down or up, we would probably use sine. Okay, so sine, now our magnitude is 1.2, but because you went down first, you would say it's negative 1.2, because it's the reflection over the x-axis there. And then we would have some value for t plus our vertical translation, which we moved up to an average of 3.4, not at 0. Now all we need to do is find our k values, but in this case it would be our omega value, so that fancy W. Now remember, period, which is 8.8, is also equal to 2 pi over omega. So we want to find the omega in this case, which is kind of like the k value, just for harmonic motion. So I want to multiply both sides by this fancy W, and then divide by 8.8. Okay. Now you get 2 pi over 8.8, but we don't really write fractions with decimals in them, so I need to move this decimal over, so make 888, but that also changes our 2 to be 20. Okay, so now we have 20 pi over 88, and now let's reduce it. So I can take 2 out of it, make it 10 pi over 44. Let's take another 2, gives me 5 pi over 22. So this would be my omega that I'm going to put in. So 5 pi over 22. And so that would be a example of the function that we're talking about. Now if you wanted to use cosine, okay, cosine would have the same magnitude. It would have the same omega value, or k value. The only difference, and it would have the same vertical translation, the only difference would be the phase shift, because you're not going to start cosine at that 0, 3.4, you'd have to start at a different one. So because you're starting at a negative one, you would go to the 2.2 point. That would be on the negative side of cosine. So that would just mean our phase shift would be a minus 2.2 to the right. So this would be also an answer. Okay? So you have two different options. You could have infinite many functions that you could write depending on how you wrote the phase shift. Most people will use it this way because there is no phase shift, so it's easier to write it that way. Okay? So here now, letter B, if we go back, reread what it wants to know when is the first time that the brightness is 3.4 after time 0. Okay, so if you go back to our picture, now that means that I'm not going to be looking at this point because that's time 0. So after that, when does it come back to 3.4 for a y value? It would be at that point, which we graphed. So B is actually quite easy. So after 4.4 days would be our answer. Okay? Now for letter C, they're asking the star's brightness is considered superlative when the magnitude is above 4.5. So we want to find the first time interval after time 0 for which this happens. Okay, so we need to do a little bit of a calculation to figure out what time t is when your graph is 4.5. Okay, so let's start with setting y equal to 4.5, and let's use our first function that we had. So negative 1.2 sine of 5 pi over 22 times t plus 3.4. Okay? So now here I want to solve for t. So I have to subtract 3.4 to both sides. So it gives me 1.1. Now here, the next step would be dividing both sides by the negative 1.2. That gives me negative 0.916 repeating. Leave that in your calculator so you can get an exact value here. Okay, now remember, this is all a part of your angle, so I need to get rid of, or get what I want, I need to take out the sine. So I need to do inverse sine of my answer that I have. That leaves me with 5 pi over 22 times t. So doing the inverse sine of this gets me, now make sure that your calculator is in radians, because our time is not going to be in degrees, so we want a radian measurement to help us describe our values better, because degrees wouldn't really tell us or match up with our time, which is 2.2, 4.4, those kind of values. So we need to use our radian measurements. So I get a value of negative 1.1596. Now, that doesn't really quite help me because it's in the negative region. So I need a value that actually falls where I want it to be. Okay? So this is not in between 0 and 2 pi. So if I add 2 pi to it, that gets me 5.124, let's say, which is a little bit more helpful. So it's like 5.12 days. Okay, we can't really have negative time, so we don't really want that. It's negative 1.15 because it wouldn't make sense. Okay, so now I need to multiply both sides by 22 over 5 pi. Okay, so then that stuff cancels out. You're left with time. Okay, and then here that gets me 7.175. So let's round it to the nearest. It says 2 decimal places, so we need 7.18 days. So there's an answer. Now, if you go back, think about our picture. Okay, so then 7.18 days would be roughly about right there. Okay, Now it's not exact, but it's somewhere about there. And plus my picture is not perfect. Let me make just a line here. Okay? Now I wanted an interval, okay? And this is only one value. Now if you look before that, like here at 6.6, we're above 4.5, so there should be more values that are above 4.5 for this interval. So we want a value somewhere in here. So some point where it's greater than 4.5, but we don't know what that value is. But if you break this apart, this picture, into your quadrants, it might make it easier to understand. So because of the period, okay, we've changed it from pi over 2, pi, 3 pi over 2, and 2 pi into 2.2. So this is quadrant 1 right here. Okay? For 4.4, it's like pi, so then this is like quadrant 2. From here to 6.6, this is quadrant 3. And then over here to 8.8, this is like quadrant 4. Okay? So we have an answer in quadrant 4. So there's one answer. Okay? Now I need another answer, but the answer should be in quadrant 3. So let's go back to when we did our inverse. Okay? So this 5.124 number. So if you can kind of get your calculator back to that point. So we did our 1.1 divided by a negative 1.2. Took the inverse and then added 2 pi. Okay? So that answer is the answer that is in the fourth quadrant. Okay? But we want a value that's in the third quadrant. So using our reference angles to help us out, I'm going to take 2 pi, and let me write this, so 2 pi minus the 5.124, or do my second answer because I re-put it into my calculator. So I get 1.1596, kind of like this number that was negative, okay? But just reflecting it back over the x-axis to get the positive of that value. So that's why they kind of look matchy-matchy. So then from there, that's in the first quadrant. Now I need to get to the third quadrant. So to go back, I actually add pi to this value, and that gets me, let me write what I'm doing. So add pi to get to the third quadrant, and it gets me 4.301. Okay? So then that would be my third quadrant value. So I'm going to do the same thing I did to the 5.124 to the 4.301. So I'm going to write an equation here. So 4.301 is equal to my 5 pi over 22 t. And so now I need to multiply both sides by the 22 over 5 pi. So this will get me my second answer. So then I can create an interval in between these two values. So times 22 divided by, now make sure when you do the division of 2 pi, you put it in parentheses, because if you don't, then you'll just divide your answer by 2, and then you'll multiply by pi, which is not what you want. So now I've got a value for t that is 6.02 days. Okay? And so then that would be my other value. So now my interval between the two, because that's what they want for an answer, let's put that answer in purple. So 6.02 or is less than t, because you don't want to include that time because it says above, not including. So 6.02 days is less than t, which is less than 7.18 days. And so that would be our answer for this problem which is the interval that they were talking about, where where this delta prime is superlative based on its magnitude. Okay? Have fun.